TopMedTalk.
Hello and welcome to TopMedTalk. It's Desiree Chappell joining you virtually for a conversation we're having today with my friends in London, UK. And that's United Kingdom if you're here from the US, not University of Kentucky. So I'm joined by, everyone knows, my former partner in crime, who is not our editor-in-chief anymore, former editor-in-chief of TopMedTalk, Monty Mythen. Hello, Monty.
Hey, Desiree, we missed you today.
Monty, you are in a new role now.
I am. So I think I've shared this on TopMedTalk for quite often recently. As of August the 1st last year, I joined Edwards Lifesciences as an employee, but they have allowed me to wear my Emeritus Professor of Anaesthesia at UCL hat intermittently and to co-anchor with you on TopMedTalk when it's deemed to be appropriate.
Yeah, we've had a lot of fun doing that. And then
we're going to be
saying
hi to Thomas Sheeran in a moment. And part of his disclosures is he's been working for Edwards Lifesciences for a little bit longer than me.
Yes, exactly 1 year longer. And same story, I'm still a professor at the University of Groningen in the Netherlands. So I'm speaking with two tongues, if you will, and both of my employees are aware of each other. Yeah. So that is...
But we have an obvious conflict of interest, and TopMedTalk has many sponsors, and one of them is Edwards Lifesciences. So but I hope we can speak from the heart about peer-reviewed evidence that's recently been published.
Yeah.
Well, we miss you, Desiree, but we've been here in London, very close to University College London, where I'm still an emeritus professor and was on staff until relatively recently. We're at an iconic London venue, probably known around the world. The Institute is probably known around the world. That's the Wellcome Institute. We're in the building that's called the Wellcome Collection on the Euston Road. And we've been there today having a hemodynamic forum with about 100 of our colleagues from around the country and actually around other countries as well. We did have some visitors who owned up from coming further afield. And we've been discussing hemodynamic measurement and monitoring. And I'm joined here by two familiar voices. I'm joined by Professor Thomas Sheeran. Say hi, Thomas.
Hi, Monty. Hi, Desiree. Hi, Simon. Spoiling who is the third participant.
Sorry, the third participant is Thomas. You might want to introduce him.
Yes, the third is our lovely friend, Dr. Simon Davies from lovely York in the UK.
Excellent. Great to be here. It's been a wonderful day, hasn't it? Some really good education, some great questions.
Yeah, I mean, I think the wow moment, again, remains the physiology lab, where we not only show what HPI, I think we've said enough about HPI, the hemodynamic predictive index on TopMedTalk, you can look it up if you want to, about the relationship between the blood loss, the HPI changes, and a true manifestation of hemodynamic instability, which is the microcirculation. Why don't we dive straight into that, Simon? Remind us about what we did in the lab and what we've done in those publications.
So in the lab and some of our publications, we've done a hemorrhage model in a porcine model, so anaesthetised, lots of instrumentation, so very highly monitored. And essentially we've taken out varying degrees of blood volume, ranging from about 1 up to 10%. And what we've consistently seen in all the models is that we have normal hemodynamics, we have some sense of instability from our advanced monitoring, but with a normal monitoring screen, we've got microcirculation dysfunction, the gut doesn't have flow, and I think it just opens people's eyes, doesn't it? When they see those pictures of normal bedside monitor, no flow or minimal flow in your gut circulation, they kind of have that light bulb moment.
There's been debate for the last couple of years about the validation of HPI. We've touched on it recently in an interview we did at the World Congress. There's 2 new papers come out that we'll get to in a moment. But we and others have been working for a number of years now on the fact that the prediction of hypotension is really not very interesting. It's really the current state of hemodynamic stability or instability that's the point.
And that's what the algorithm HPI was actually designed to do. It was designed to quantify the amount of instability within a personal or a biological system. And the whole hypotension thing is when it all got too much at the end. So that's the end of the story, which we're not that interested in, because we can stop that before it happens.
And if folks listening haven't seen the virtual physiology lab, it's available in about 4 different sites now. We can put at least one of those links in the show notes. And, in it, I think we demonstrate very, very clearly the disconnect between the macrocirculation and microcirculation. And that whatever it is that informs HPI changes way, way in advance of any other pressure changes, whether they be blood pressure or CVP, etc. Thomas, let's touch for a second on those 2 publications that are coming out. Remind us of the recent history and criticisms of the early validation of HPI that's played out in a little bit in the literature, which we celebrate, the peer-reviewed literature, but in my opinion, far too much in ungoverned and unpeer-reviewed social media.
Yeah, if we go back to the first validation paper that you are referring to, it used data from hundreds of patients from the ICU, from the OR, and also from a public database to validate that variable that is predicting hypotension. And to do that, it was deliberately chosen to distinct hypotension, which was defined as a mean arterial pressure below 65, from non-hypotension, which was defined as a blood pressure above 75, mean arterial pressure above 75. So the range between 65 and 75 was deliberately excluded from that analysis because blood pressure might vary go from 64 to 67 and around that age. So to have the clear distinction, it was chosen to have that part of data not analyzed because you don't know if it goes to hypotension or non-hypotension.
And the statisticians who are interested in this area, they have taught me that it's all about whether you have a boundary that you look at, grey zone, you can call it other things,
Yes.
or a clean cut point. But so
Yes.
why the 65 to 75? Why not just a different number?
First of all, it's a very common problem or a method in machine learning to have this clear distinction and to have a gray zone where you exclude the data from being analyzed, to have that clear distinction.
So that was the debate. Now, Simon, you've been involved in the challenges that have come forward more recently in people saying that in that original paper, you didn't give mean arterial pressure per se a fair rub of the green, as that's an English expression that you would understand.
I understand that. We didn't because we have no interest in mean arterial pressure.
Let's imagine we do for a little bit. What was the criticism about the... Because as I saw that there was an explanation that was then published to say when you did it, you did this boundary effect when you looked at HPI, but you didn't use this boundary effect when you looked at other variables.
No, we didn't. So the boundary effect for HPI, I think Thomas alluded to, was we wanted clinical endpoints.
Yeah.
And so below 65 milliliters of mercury, there's higher incidence of AKI and myocardial injury. Above 75, there's a lot less. The zone in the middle, the grey zone or zone discrimination, that's where you can't tell. So we try to dichotomise harm from no harm as it related to hypotension. When we analysed MAP and other values, we didn't apply that same zone of discrimination. And particularly regarding to MAP, the reason we didn't is that we're just not quite sure why you wanted to use MAP to predict itself. So it's the same variable predicting itself. And whenever you do that with time series data, you always get high AUCs.
And we'll come back to that one in a second, because I think I've got my head around that one now, the mathematical coupling component of it. In that original Anaesthesia and Analgesia paper, there was a change published to say that information was always in the paper, but it was buried in the appendices, etc. And some critics said you should bring it right forward. Is that a reasonable summary, Thomas? They said, we're not saying you got it wrong the first time. We're saying that you should be clearer about the fact you weren't necessarily comparing apples to apples.
That's right, but let me come back to the initial question: why did we choose that exclusion, or what's the critics that has been raised to that? Because it has been said statistically it may alter the ROC, the receiver operating characteristics curve, to a higher value if you do such a boundary exclusion of data, and these critics have tried to prove that by simulated data that they just invented on their computer to prove this. And this was the reason why we, taking it serious, reanalyzed our data, or much more data that we have now available from the different studies, to reanalyze and revalidate that same algorithm that has been validated originally.
So I wasn't right in the tent for the early validation, whereas you guys have travelled the whole journey with the team at Edwards Lifesciences and a number of international collaborators around the world. I understand why you did what you did, but I also understand that for the average reader, it's going to sound as though you might have been cheating in some way. So now, to hold that for a second, I don't want to antagonise you too much, because I'm not suggesting you were cheating. But the reasonable response to the suggestion that you didn't compare apples to apples and oranges to oranges was to go back and get hold of all the data you could get hold of, and reanalyze it in a number of different ways. Now, as I understand it, Simon, and I've travelled this new journey with you, so I think I've got it. You looked at it by looking forwards. You can explain that to us in a second. You looked at it by looking backwards. Explain that to us in a second. You looked at it using a boundary, and you looked at it using a clean cut. So you've addressed the question in every way we can think of and compared apples to apples, which we thought we had before. You all thought we had before. Now, to explain those components to us.
So the original validation study used a backwards analysis. So what we did was identify hypotension, and then look backwards and see what the predictive variable was.
Yeah.
And by doing that, you don't have to adjust for any interventions that might affect your blood pressure.
Mm-hmm.
So it takes out interventions. So we also had the zone of discrimination, or the grey zone, for the reasons that we said before. AKI and MINs are high above one, low below the other, so it's clinically very validated. And we used a balanced selection of data points.
Yes.
So hypertension was less than 65. Non-hypertension was the midpoint of a data section above 75 millimeters of mercury. Now, the reason for that was there was a lot more non-hypertension than hypertension. And to use ROCs effectively, you have to balance the amount of data. So that allowed to have a balanced selection. And so doing that, we showed that HPI is a very good predictive hypertension up to 15 minutes in advance. Now, there were some comments that actually that doesn't reflect the flow of data in real world. You should look forwards. And that in our general practice, we use all the data points.
Yes.
And those aren't unreasonable comments, actually. And we were aware of that. We had very good scientific reasons for doing it the way we did. But equally, we listened and were flexible, and we were happy to analyse it in a different way. So we took more patients, this time over 2,000, 4.5 million data points, and we did what was suggested in literature. We did a forward analysis. So we look at HPI or stroke volume, and we look into the future. Is there hypotension? Now, we have to exclude some things due to interventions, but that's part of the course. We use every single data point, so we selected out no data at all, and there was no grey zone or zone of discrimination. And the predictability remains exactly the same.
So, in other words, the original paper was right. All subsequent papers that have looked at it, of which there's a range of them now, have reached the same conclusion about HPI's predictive ability.
Yep.
And the new paper published reinforces that point. So the area under the ROC curve is very high. You'd think end of story. Is that fair summary, Thomas?
Yes, I would say these critics have raised a hypothesis saying that our initial validation was wrong. We now, with a new study, disproven that hypothesis. So we proved that the original was right with a new. So this hypothesis is off the table, I guess. That there were any tricks or any.
Well, it's a scientific debate, and it's more a statistical debate. I would suggest, but it's a very, very valid point, I think, that was addressed.
The summary, Monty, it doesn't matter which way you do it, backwards, forwards, grey zone, no grey zone, it doesn't change the predictability. The AUCs remain almost identical.
Now, in social media, we're seeing reinforcement of the point that mean arterial pressure has an area under the ROC curve that's very similar to HPI. So the suggestion is if we take whatever the blood pressure is at the moment, it has a relationship to the blood pressure in the future. Now, I recognize this as mathematical coupling, is the way I learnt about it. I lived through the oxygen kinetic debates of the 1980s. You can find a number of editorials and articles in the oxygen kinetic world, which were mainly driven by the fact that people were claiming a relationship with oxygen delivery and oxygen consumption, where both were calculated using almost all the same variables. If you put a pulmonary artery catheter in, you measure cardiac output, you add the hemoglobin, the only variable is the mixed venous saturation. So if you look at a relationship between the two, they're going to relate.
Yeah.
And I think we got there eventually with the reviewers. That's mathematical coupling, which is extremely well known. So
well, for me, as you say, it's a known, and we've known it for a long time. That is just very simply mathematical coupling. And we illustrated that in our paper. We looked at stroke volume, we looked at heart rate, and we looked at mean arterial pressure. And whatever threshold you choose, if you use the same variable as the predictor and outcome, you get higher UCs at whatever threshold you choose.
Yeah, and I get the impression, because now it's published that way, that the reviewers got to a point, particularly the statistical reviewers, saying, yes, we've known about this for a long time, that's just simple mathematical coupling.
That was quite a journey, though, wasn't it? So at the start, it was. Of course, you can use MAP to predict MAP. And then eventually we got to it. Oh, actually, no, you can't.
When we presented it in Brussels, we were a little bit laughed at by some of our senior colleagues who said, now you've told us the Earth is round. Are you going to tell us anything useful? So is that fair? I think that's almost a direct quote, Thomas.
Yes, that is what how the experts react. However, for rather a big group of clinicians, it seems to be quite attractive, the idea that mean arterial pressure can be used to predict itself, so that we just look at mean arterial pressure to see if a patient was going to be hemodynamic unstable or hypotensive. So it is an attractive solution. However, it does not work. And this is what we've shown repeatedly.
It's not even an attractive solution, I don't think. If you took, say, the optimal cutoff was 75, then you treat 75. I mean, it might be 77 for 2 hours, but now you treat the 75. Or it might have gone from 110 to 75 in 60 seconds, but then you don't treat it because it's above the threshold. Clinically, it doesn't really quite make sense.
And even more, we do have blood pressure measurements around for more than 100 years, and it doesn't prevent us from having hypotension. If you look at the hypotension literature, we do see hypotension between 50 and 80% of cases undergoing elective non-cardiac and also cardiac surgery. So we are not able to prevent hypotension despite having access to mean arterial pressure measurements for a long time.
And alarms have been there forever, and there's studies where they've set the alarms and they haven't changed patterns of behaviour, etc. So, I mean, if people want to take the blood pressure alarm approach, I completely understand that, if they want to do that. But once you get to that point, let's imagine you use HPI, let's imagine you choose a blood pressure threshold and alarm. What do you do next? Because the HPI bit, as far as I get it, is not the HPI in isolation. No. It's part of the Acumen suite, and the really important part of it is what's the underlying cause.
So you get to a blood pressure threshold,
Yep.
and then you use HPI to decide, well, what's the chance of becoming hypotensive in the future? If HPI is high, then you've got a high chance, so you need to look around and examine what the underlying physiology is. What's the cause of that instability that will lead to hypertension? Do I need to give fluids? Do I need to address afterload? Do I need to address contractility? And all that information is on the screen on the monitoring that we use. At the same blood pressure threshold, if HPI is 5, you can sit back and not worry. You're not going to be hypotensive in the future. So you use it as a discriminator between those who will become unstable and those that won't.
And the underlying cause is increasingly being referred to as now endotypes, for example,
Yep.
of which I think there's 4 major ones. Is that, Thomas?
Yes.
4 major.
Yes.
Which are
the ones that Simon mentioned, so hypovolemia, contractility, afterload, and bradycardia being the fourth one.
And depth of anaesthesia, I presume, is in the background there, but not necessarily measured by it. So we've seen you get to the point, you get to the hypotension. We've seen this sort of global reaction where people are giving less and less fluid, and the knee-jerk reaction to the blood pressure dropping seems to be the administration of quite often a pure alpha agonist, of which we hear phenylephrine mentioned a lot. Now I know a lot more about HPI, I've got a lot closer to it. And the animal work we've done together. The really interesting bit to me is as the HPI is rising, so hemodynamic instability is going up, if you then look at what the underlying cause is, do you have any sense of how often there's an abnormality that we would recognise as hemodynamic instability? Am I making sense of that? So the HPI gets to 50, for example. How often is it preload? How often is it afterload? How often is it it's contractility after bradycardia?
Generally a rule of thirds.
Wow, okay.
It's about a third of it's preload, about a third of it's contractility, and about a third of it is due to afterload. But our default response appears to be to start a vasopressor of some description. That's the way the sort of treatment seems to have gone, and it's not uncommon now, I think, when you induce anaesthesia to see the vasopressor infusion.
That will mean that in 2/3 of patients we are giving the wrong treatment.
Yeah.
Wow.
And that's the interesting bit that we need to look at next. I mean, that's the direction of travel. I know the work's ongoing. I know we can look forward to the publications. But I think we're really interested is what is the positive predictive value of an HPI number telling you that there's actual or impending hemodynamic instability manifest as something like an abnormality of contractility, an abnormality of preload, an abnormality of afterload, etc. Because, that's the...
Yeah, when you look at HPI over 50, you will identify a physiological abnormality in over 85% of individuals.
Okay, so that's the interesting bit.
Yeah.
But do we know the same for MAP?
I can't remember. It was somewhere in the sort of 30-40%. I can't remember off the top of my head.
Okay. So that's where we're going in the direction of travel.
Yeah.
So the really interesting bit, I think, is one is congratulations on your original work playing out from the point of view of demonstrating the fact that the original observations were valid.
Mm-hmm.
Thanks for the explanations about MAP and mathematical coupling and demonstrating that. There's the other final thing is there's statements in there that says HPI of 85 is same as a MAP of 72 or 73. Now there's two papers coming out side by side in anesthesiology that when I read them seem to have the same data, different size and different number of patients, etc. And the same curves. Thomas, you might be able to describe this curve, the same curves that compare MAP to HPI.
Yeah, the beautiful curve that we have in our paper, it is like an S shape but mirrored. So, and it's very broad. So, and you can draw a line and see at a certain blood pressure, let's say miniature pressure of 72 or 75, you can have a HPI value of 10, as low as 10, or as high as 100. And also the other way around, when HPI is 50, you can have a blood pressure of 70 or 85 or something. So it is a very broad relation. It's not a linear correlation, so you cannot replace the one by the other.
And we see in other histograms, there's the follow-up to the EU Hypertext study. There's a histogram published which shows that the median map of the histogram for HPI at 85 is about that 70 number. But it's a median, so about half are higher and about half are lower. So I'm lost on the idea that they're equal to each other. So I just encourage people to look at, there's a large number of graphs out there that are drawn in the similar way. And to my eye, when I look at them, I'd be delighted to be corrected. Although you can find an average number that's in that region, the spread is enormous. The spread is enormous.
Exactly. Average number doesn't tell you anything about the individual patient.
No, as most of the data reported, that there is an average linear relationship between HPI and MAP.
Yeah.
Also an average non-linear relationship with HPI and MAP. But it's the average data that's being reported, and the standard deviation or the interquartile range is rarely reported. And in the paper that said you could use a MAP of 72 as equivalent to a HPI of 85, when you look at that MAP of 72, the variation in HPI was huge.
So I encourage people, if you are interested in this subject, if you've listened this far through this podcast, there's a chance that you might be. Please do read the papers. I think that's very, very important if you're very interested in this subject. Don't just read the headlines and don't just read the abstracts. Please do look at the figures that we're referring to. And if you think that we're still misinterpreting it, please don't hesitate to go to write a letter to the editor of a peer-reviewed journal so we can have a debate in the peer-reviewed environments. Whatever you write in social media, we will not be responding to, if you see what I mean, because that's not peer-reviewed, and a sensationalized, tilted one side of the argument is not where any of us are going.
No, it's not professional.
Well, you don't even read it, Simon.
Agreed.
I've seen social media. I'm just not on it.
So that's not to be mean to anyone. We have to. We need to get back into the world of peer-reviewed debate and discussion, and we have no hesitation with being proven wrong or being challenged. We're scientists. That's what we're here to do.
Very much so.
Thank you. Sorry, Desiree.
Thank you, guys. That was a fantastic conversation. As I've been sitting listening, as a clinician myself who's very familiar with this technology and been using it in practice, I think that, when you see these social media posts, when you see people pushing back on some of these things, some of it resonates because, yes, you do see a trend of HPI going up and blood pressure going down, for sure. For a clinician using it very often, and we do this at my place of practice, I have personally used it quite a bit. And what I have found is we're not waiting for that number of an HPI of 85. As Simon said, we're starting at 50. Whenever we start seeing HPI go up, then we start looking at all the issues. So to me, I'm not waiting for I'm not waiting for the patient to get hypotensive. I'm not waiting for their blood pressure, their mean to get to 75, or maybe I am, and I'm okay with that. but I know everything else that's going on with that patient. Where if you just have the mean arterial blood pressure and systolic, diastolic, that is not helpful. If you're seeing trends, you have no idea what's actually going on. I mean, you may have some idea because you look and your gas is up, or that you have just given a dose in your epidural or something like that. But I mean, that's, to me, the most important point is like, yes, I do see those trends, but beyond that, how is this technology actually impacting the level of care that I'm giving? And it really elevates everything that I'm able to see and do for my patient. And so when I think, I'm not necessarily, I'm not a researcher myself. I can read papers, but sometimes they don't mean as much to me or colleagues who want to just get the main point of an abstract or something like that. I think it's really important to have these discussions about how all of the literature translates into actual clinical practice. So that's what I have to say about it.
Well, Desiree, I completely agree with you. I think everything you said sort of really resonates. It's not waiting until it's 85 and it's too late and you're sort of spiraling down the drain. It's that proactive approach that makes a difference. So that early identification of instability, of not just looking at one number, but changes. So delta HPI is just as important. If it's gone from 20, 40, 60 over a minute, then that's implying there's something going on and you have to act. And I think that's it's a really sensible and pragmatic way of how to use this.
And let's not forget, Desiree, that it's not all hypotensive events that can be predicted. For example, if a surgeon comes and puts a clamp on a big vessel, or if a cardiologist starts a rapid pacing, these are, of course, external events that cause this, what the literature referred as a mirror effect. So simultaneously drop in blood pressure and rise in HPI, because HPI, of course, cannot predict these acute changes. So you cannot tell by looking at the arterial pressure waveform 2 or 5 minutes before that event that this will happen. But the majority of cases that we are talking about that are caused by the decompensation of the physiological compensatory mechanisms, these can be detected by the HPI technology.
And I think, Desiree, I think
if HPI can start predicting surgeon behavior, that would be fantastic.
We agree on that.
And Desiree, I think all of us have been in forums where people have seen the microcirculation images, and I think that's the aha moment for a lot of people. So the virtual physiology lab is, as I said towards the beginning, it is accessible in a number of different formats now. We can get some links through to that. So anyone who still wants to try and understand what we're getting at here, during that controlled hemorrhage in an animal model, when HPI rises, the microcirculation goes down, basically, and that's well in advance of a blood pressure change. That's the really interesting bit. That, to me, represents hemodynamic instability. And you've got another paper coming out, Simon, in this series.
We do. I've been promising it for ages, haven't I, Monty? But it's finally almost finished. And I think it shows the same thing. This time we did smaller hemorrhages, so 1% at a time. And for every 1% hemorrhage, your microcirculation became more and more dysfunctional. Once you got to about 5% volume loss, then you had pretty significant disconnect of your gut microcirculation.
And HPI was up and blood pressure was stable.
HPI was up around about 50 was the optimal cutoff, and everything else was in normal clinical ranges.
Great stuff. Well, we look forward to seeing that paper soon. Yeah. Desiree, I'm going to ask you to bring us home in a second. Gentlemen, thank you very much for your time. Thank
Always
you
a pleasure, Monty.
Pleasure.
And Desiree.
So it's good to be here at the Wellcome Collection. Thank you very much to Edwards for supporting today's event. It'll be in the show notes, but those of you, I'm sure, all know now, both myself and Thomas are employed by Edwards Lifesciences, but I'm still an Emeritus Professor at UCL and still allowed to do a little bit of TopMedTalk. Thank you for that, Desiree. If anyone had a contrary view informed by a significant data set and they wanted to chat to you about it, I'm guessing you'd be delighted to interview them.
Yeah, absolutely. We would be happy to interview anyone that has varying opinions about the subject matter, that any subject matter actually that we have on TopMedTalk, but especially this, we do have a lot of conversations about it. So reach out. Simon and Thomas, it's wonderful to have you guys back on the show and work through some of these. This is an ongoing evolution of a story. We've been talking about this for a long time, and I think that it's always good to kind of break it down to help our listeners understand everything that you guys have been working on and the new technology and the different monitors that are available out there. So thank you very much for joining us. And you can always find us at TopMedTalk.com. There is a ton of content about all of the things that we described today. I think we've had some commentary about the virtual physiology lab and the gut microcirculation. We really break that down in some of our other podcasts. So please do check that out. Give us a thumbs up on YouTube if you're listening to this on YouTube. If you're on social media and you've heard something today that piques your interest, please reach out to us and let us know. And as Monty said, if you have anything that you want to put out there or commentary, peer-reviewed journals are the best way to go about that.
TopMedTalk. Thanks for downloading TopMedTalk. Don't forget to subscribe, check us out on YouTube, and of course on social media. We're on Instagram, Facebook, and X. Also, it's important to remember that TopMedTalk is the broadcasting arm of EPPOM, evidence-based perioperative medicine. We'd love you to find out more about that, and the way to do that is eppom.org. Check out our website and find out about some of the incredible conferences we're going to be arranging across the year. eppom.org.